Good morning, children. Today, let's discuss about the chapter Metals and Non-Metals. Elements are classified as metals and non-metals on the basis of their properties. Examples of some metals are iron, aluminium, silver, copper, etc. Examples of some non-metals are hydrogen, nitrogen, sulfur, oxygen, etc. Now let's compare the physical properties of metals and non-metals. The first physical property is luster. Luster is nothing but the shining surface on the metal or the non-metal. Most metals have shining surface, whereas non-metals do not have shining surface. Here, the exception is iodine. Iodine is a non-metal but it has lustrous property. The second property is the hardness. Metals are generally hard. Here, the exceptions are sodium, lithium and potassium, which are very soft and can be cut with knife. Whereas non-metals are generally soft. Here again there is an exception, which is nothing but the diamond, a form of carbon which is the hardest natural substance. Next physical property is state. All metals are solids in state. Exception, mercury, which exists in liquid state in room temperature. Whereas non-metals all exist as solid or gases. Exception here is bromine, which exists in liquid state. The next physical property is called as malleability. Metals can be beaten in thin sheets, which is called as malleable. Gold and silver are most malleable metals, whereas non-metals which are non-malleable. The next physical property is ductility. Metals can be drawn into thin wires. This is called as ductility. Most metals are ductile in nature, whereas non-metals are non-ductile in nature. The most ductile metals are gold and silver. The next physical property is conductivity of heat and electricity. Metals are good conductor of heat and electricity. The best conductors of heat are silver and copper, whereas non-metals are poor conductors of heat and electricity. Here, the exceptions are graphite, which is an allotrope of carbon, which is a non-metal, which is a very good conductor of heat and electricity. The next physical property is density. Generally, metals have high density and high melting point. Here, the exceptions again are sodium and potassium, whereas in non-metals, they all have low density and low melting points. The next physical property is sonority. Metals produce a sound when striking on a hard surface. It is said to be sonorous. All metals are sonorous, whereas non-metals are non-sonorous. The next physical property is oxides. Most of the metallic oxides are basic in nature, whereas non-metallic oxides are acidic in nature. But there are certain exceptions where metallic oxides called as amphoteric because they show both basic as well as acidic properties. Few examples of amphoteric oxides are aluminium oxides and zinc oxides. Now, let's learn about the chemical properties of metals. Let me react the metals with air first. Metals combine with oxygen to form metal oxide. Few examples are when copper reacting with oxygen, it forms copper oxide, which is black in color, whereas aluminium reacting with oxygen gives rise to aluminium oxide. Magnesium reacting with oxygen gives rise to magnesium oxide. The reactivity of different metals are different with oxygen. If you take sodium and potassium, they react so vigorously that they catch fire if kept in open, so they are kept or they are immersed in kerosene. Surfaces of magnesium, aluminium, zinc and lead are actually covered with thin layer of oxide which prevents them from further oxidation. Iron does not burn on heating, but iron fillings burn vigorously. Copper does not burn, but it is coated with black copper oxide. Gold and silver does not react with oxygen at all. Now let's discuss about amphoteric oxides. Likewise, I told you before, metal oxides which reacts with both acids as well as bases to produce salts and water are called as amphoteric oxides. Now let me take an example of aluminium oxide. When aluminium oxide is treated with HCl, which is an acid, aluminium chloride is formed along with water. This shows that aluminium oxide shows the basic property when it is reacted with acid, it gives you salt and water. Now, let me take aluminium oxide as its acidic property. When aluminium oxide reacts with sodium hydroxide, which is a base, it gives you sodium aluminate, which is a salt, and along with water. Here, aluminium oxide behaves as acid. This shows that aluminium oxides are amphoteric in nature. Now let me react metals with water. When metals react with water, metal oxide and hydrogen is given. When the same metal oxide again reacts with water, metal hydroxide is formed. Every metal reacts with water differently. There are certain metals which reacts only with cold water. Sodium, potassium and calcium only reacts with cold water. Sodium and potassium reacts vigorously with cold water and it catches fire. When sodium and water reacts, it forms sodium oxide along with hydrogen gas. The hydrogen gas catches fire. The same goes with potassium as well. Calcium reacts with cold water and the calcium starts floating on the water. The reason is being the hydrogen gas bubbles which sticks on the calcium and allows the calcium to float on the water. Just like calcium, even magnesium reacts with water and starts floating on the water as the bubbles of hydrogen sticks onto their surface. There are certain metals called lead, copper, gold and silver. They do not react with water at all. These are the chemical reactions of the metals reacting with water. Now, let's learn about the reaction of metals with dilute acids. When metal reacts with dilute acid, salt along with hydrogen gas is produced. Copper, gold, silver, mercury do not react with dilute acids at all. Let's see few reactions. When iron reacts with hydrochloric acid, it gives you iron chloride along with hydrogen gas. When magnesium reacts with hydrochloric acid, it gives you magnesium chloride along with hydrogen gas. Zinc reacting with hydrochloric acid gives you zinc chloride along with hydrogen gas. Whereas the aluminium reacts with hydrochloric acid, it gives you aluminium chloride along with hydrogen gas. Now let's learn about the reaction of metals with solutions of other metal oxides. If metal A reacts with the salt solution of metal B, it gives rise to salt solution of metal A and the metal B alone. Reactive metals can displace less reactive metals from their compounds in a solution form. Now let's learn about the reactivity series before we get into these equations. The reactivity series is the list of the metals arranged in the order of their decreasing activities. The most reactive metals are potassium, sodium, calcium, magnesium and aluminium. As it goes down, the zinc, iron, lead, hydrogen, copper, mercury, silver, gold, which are the least reactive metals. Keeping this as the basis, now let's learn about the reaction of metals with non-metals. Reactivity of the elements is the tendency to attain a completely filled valence shell. Atoms of the metals lose electrons from their valence shell to form cations, whereas the atoms of the non-metals gain electrons in the valence shell to form anion. Now let's discuss about the formation of sodium chloride. The bonds formed between the sodium and chloride ion are called as ionic bonds, and these compounds are called as ionic compounds, also called as electrovalent compounds. Now let's learn about the properties of ionic compounds. Its physical nature. They are solid and hard but generally brittle. Melting at the boiling point is the second point for the ionic compounds. All ionic compounds have high melting and boiling points. The third ones being the solubility. Generally soluble in water, but they are insoluble in solvents such as kerosene and petrol. The fourth one being the conduction of electricity. Ionic compounds conduct electricity in molten state and also in solution form, but they do not conduct electricity in the solid state as they have strong electrostatic force of attraction. Now, let's learn about the occurrence of metals. The Earth's crust is a major source of metals. Seawater also contains some soluble salts such as sodium chloride, magnesium chloride, etc. The elements or the compounds which occur naturally in the Earth's crust are known as minerals. At some places, minerals contain a high level percentage of particular metals and the metals can be profitably extracted from it. These minerals are known as ores. Now let's discuss about the extraction of metals. We have learnt about the reactivity series of metals. Having its knowledge, you can easily understand how a metal is extracted from its ore. Some metals are found in the Earth's crust in the free state. Some are found in the form of their compounds. The metals at the bottom of the activity series are called as least reactive. They are often found in the free state, or you can call it as native state. For example, gold, silver, platinum and copper. Copper and silver are also found in the combined state as their sulfides or oxides ores. The metals at the top of the activity series, that is potassium, sodium, calcium, magnesium and aluminium, are so reactive that they are never found in the native as free elements. The metals in the middle of the activity series, zinc, lead, iron, etc., are moderately reactive. They are found in the Earth's crust mainly as oxides, sulfides or carbonates. You will find out the ores of many metals as oxides. This is because oxygen is a very reactive element and is very abundantly present on the Earth. Thus, on the basis of reactivity, we can group the metals into the following three categories: metals of low reactivity, metals of medium reactivity, metals of high reactivity. Different techniques are used for obtaining the metals falling in each category. The next step is the enrichment of ores. Ores mined from the earth are usually contaminated with large amount of impurities such as soil, sand, etc., which is called as gangue. The impurities must be removed from the ore prior to the extraction of metal. The processes used for removing the gangue from the ore are based on the difference between the physical or chemical properties of the gangue and the ore. Different separation techniques are accordingly employed. Now, let's learn about extracting metals with low reactivity series. Metals low in the activity series are very unreactive. The oxides of these metals can be reduced to metals by heating alone. For example, cinnabar, which is also called as mercury sulfide, is an ore of mercury. When it is heated in air, it is first converted into mercuric oxide, HgO. Mercuric oxide is then reduced to mercury on further heating. Similarly, copper, which is found as cuprous sulfide, which is also called as copper gland in nature, can be obtained from its ore by just heating in air. Cuprous sulfide reacts with oxygen, gives to cuprous oxide and sulfur dioxide, whereas the same cuprous oxide again reacts with cuprous sulfide, gives you copper plus sulfur dioxide. Now, let's learn about the extracting metals in the middle of the activity series. The metals in the middle of the activity series such as iron, zinc, lead, copper, etc. are moderately reactive. These are usually present in the form of sulfides or carbonates in nature. It is easier to obtain a metal from its oxide as compared to its sulfides and carbonates. Therefore, prior to reduction, the metal sulfides and carbonates must be converted into metal oxides first. The sulfide ores are converted into oxides by heating strongly in the presence of excess air. This process is known as roasting. The carbonate ores are also changed into oxides by heating strongly in the limited air. This process is known as calcination. The chemical reaction that takes place during the roasting and calcination of zinc ores can be shown as zinc sulfide reacting with oxygen gives rise to zinc oxide plus sulfur dioxide. This process is called as roasting. Whereas when zinc carbonate is heated alone, it gives you zinc oxide plus carbon dioxide. The metal oxides are then reduced to corresponding metals by using a suitable reducing agent such as carbon. For example, when zinc oxide is heated with carbon, it gives you or it is reduced to metallic zinc along with carbon monoxide. Obtaining metals from their compounds is also a reduction process. Besides using carbon, which is coke, to reduce metal oxides to metals, sometimes displacement reactions can also be used. The highly reactive metals such as sodium, calcium, aluminium, etc. are used as reducing agents because they displace metals of low reactive from their compounds. For example, When manganese dioxide is heated with aluminium powder, it forms manganese along with aluminium oxide with exorbitant amount of heat. These displacement reactions are highly exothermic in nature. The amount of heat evolved is so large that the metals are produced in the molten state. In fact, the reaction of iron oxide, the valency 3, with aluminium is used to join railway tracks or cracked machine parts. This reaction is also known as thermite reaction. Now let's learn about the extracting metals towards the top of the activity series. Metals high up in the reactivity series are very reactive. They cannot be obtained from their compounds by heating with carbon. For example, carbon cannot reduce the oxides of sodium, magnesium, calcium, aluminium, etc. to the respective metals. This is because these metals have more affinity for oxygen than carbon. These metals are obtained by another process called as electrolytic reduction. For example, sodium, magnesium, calcium are obtained by the electrolysis of their molten chlorides. The metals are deposited at the cathode, which is negatively charged electrode, whereas chlorine is liberated at the anode, which is positively charged electrode. Similarly, aluminium is obtained by electrolytic reduction of aluminium oxide. Now let's learn about the next step, which is called as refining of metals. The metals produced by various reduction processes described above are not very pure. They contain impurities which must be removed to obtain pure metals. The metals widely used method for refining impure metals is electrolytic refining. Electrolytic refining is a process which is used for refining of metals such as copper, zinc, tin, nickel, silver, gold, etc. In this process, the impure metal is made the anode and the thin strip of pure metal is made the cathode. A solution of the metal salt is used as electrolyte. On passing the current through the electrolyte, the pure metal from the anode dissolves into the electrolyte. An equivalent amount of pure metal from the electrolyte is deposited on the cathode. The soluble impurities go into a solution, whereas the insoluble materials or insoluble impurities settle down at the bottom of the anode and known as anode mud. Now let's learn about corrosion. Silver articles become black after some time when exposed to air. This is because it reacts with sulfur in the air to form coating of silver sulfide. Copper reacts with moist carbon dioxide in the air and slowly loses its shining brown surface and gains a green coat. This green substance is called as copper carbonate. Iron, when exposed to the moist air for a long time, acquires a coating of a brown flaky substance called rust. Now let's learn about the prevention of corrosion. The rusting of iron can be prevented by painting, oiling, greasing, galvanizing, chrome plating, anodizing or making alloys. What do you mean by the term galvanization? It is a method of protecting steel and iron from rusting by coating them with a thin layer of zinc. The galvanized article is protected against rust even if the zinc coating is broken. What do you mean by the term alloying? Alloying is a very good method of improving the properties of a metal. We can get the desired properties by this method. For example, iron is the most widely used metal, but it is never in its pure state. It is because pure iron is very soft and stretches easily when hot. But if it is mixed with small amount of carbon, say around 0.05%, it becomes hard and strong. When iron is mixed with nickel and chromium, we get stainless steel, which is hard and does not rust. Thus, if iron is mixed with some other substance, its properties changes. In fact, the properties of any metal can be changed if it is mixed with some other substances. The substance added may be a metal or a non-metal. An alloy is a homogeneous mixture of two or more metals or a metal and a non-metal. It is prepared first by melting the primary metal and then dissolving the other elements in its definite proportions. It is then cooled to room temperature. Pure gold, known as 24 karat gold, is very soft. It is therefore not suitable for the making jewelry. It is alloyed with either silver or copper to make it hard. Generally in India, 22 karat gold is used to making ornaments. It means that the 22 parts of pure gold is alloyed with 2 parts of either copper or silver. If one of the metals is mercury, then the alloy is known as amalgam. the electrical conductivity of and the melting points of an alloy is less than that of pure metals. Say for example, brass, an alloy of copper and zinc, whereas bronze, an alloy of copper and tin, are not good conductors of electricity, whereas copper is used in making electrical circuits. Solder, another alloy which is made up of lead and tin, has low melting point and is used for welding electrical wires together. Thank you, children.